So let's move on. Let's move on to the last section, which is on some of the solutions that we have. This is essentially Demo Central. There'll be 5 presenters coming up, and we'll be demonstrating various tools that are available. I will be introducing a threat modeling tool that we have internally. We have plans to make that threat modeling tool available externally. We're just sort of cleaning it up right now, but we have every intention of releasing this so everyone can use it. Other demos including, Matt will give a quick explanation of code access security. Then we'll demonstrate some new features in Whidbey, then a tool that you may already be aware of, FXCOP, and then finally a demonstration of a third-party tool called Safe Apps. So the first tool I'm going to demonstrate is this threat modeling tool that I mentioned before. Now, I agree 1,000% with James, and we have our differings of opinions every once in a while. Okay, more often than not. But this is one thing we firmly agree on, and that is that threat modeling is so important. You cannot build secure software unless you understand your threats. You can't. You could, enable SSL. You could turn on IPsec. You could use PKI this, X.509 that, PGP this, ACLs, SIDS, DES, triple DES, AES, blah, blah, blah. You may win the game of buzzword bingo, but you still ship some software that gets whacked on day one. That's not how you ship secure software, just by enabling all these funky features just so you get a good review. Because if they don't mitigate real threats, you are totally wasting your time. A good example of this is there's a couple of clients that I know who enabled SSL because they thought it made their web app secure. It was quite interesting showing them cross-site scripting attacks all over SSL, showing them SQL injection attacks all over SSL. SSL mitigates certain threats, but not other threats. So the threat modeling process is incredibly important. One thing that the SQL Server team did that has been adopted by all pushes now is to do threat modeling very, very early before a push is done. In fact, the best time to do a threat model is before the product is even design complete. So another important thing about threat modeling, there we go, is that it can really help you drive some important decisions that you make in the product. So let me give you an example, a real-life example. During the Windows Server 2003 security audit, which was December last year, it took us about 4 or 5 weeks, give or take, to do the audit. And there's a lot of things that go on in the audit, including reviewing bugs, doing penetration work on particularly critical components, code reviews. But one of the other things that we do is, including engaging third parties, is to re-review threat models. Go back to the threat models just with 6 months or 12 months of hindsight. Just go back to the threat models and update them. Well, one thing that we did during the Windows security the security audit, is we went back to the, I was running the threat modeling process, went back to the IE guy, Internet Explorer team. And you've got to realize that when we'd completed this audit, the general consensus from about 40 people was the product was ready to ship from a security standpoint, except one thing. And everybody agreed on that one thing. We went back to the IE guys and we said, go back to your threat models and think about one scenario. You remember something that James mentioned is that threat models are scenario driven. Think about the use cases. And so we said, think about the threats. And I'm not talking about bugs here, I'm talking about threats, like what are the avenues of attack and what are the potentials for damage when, if someone could try to compromise a machine through IE. So what are those avenues of attack and what are the potentials for damage? So we went to the IE guys and we said, think about the threats when an admin is browsing the internet from a domain controller. I'm not talking bugs. What are the avenues of attack and what is the potential for damage? And we all agree, this is December. As Mike mentioned, we were all wrapped up March the following year. So in December, we decided to do something pretty drastic to IE. I'm sure many of you are aware of it. We essentially turned IE into an HTML 3.2 browser on the server. It does no VB script, no JavaScript, no ActiveX controls, no Java applets, and it does not host .NET Framework components. And that is the default, because it's a server. The potential for damage is immense, and the vectors out there and the avenues of attack are huge. And we recognize that we could not ship the product that way. So we ended up making this change, and this is all based on the threat models, completely based on the threat models. When we made this change, you've got to realize we're not fixing a bug here, we're reducing attack surface. There's no bugs being fixed. So we reduce the attack surface by turning all this functionality off, And we found about 40 regressions. Like 40 things just stopped working in Windows Server 2003. Like Windows Update, for example, just stopped working. That's not a good thing. So we were in a bit of a bad position here. We'd made these changes that didn't fix bugs and introduced 40 bugs with 90 days to go until we're done. This is a product that's been in development. I attribute every gray hair to Windows Server 2003. It seems like a long, long time. And with 90 days to go, we're introducing all these bugs. We decided that we would not back. We had two options. One was to back out the changes in IE, so the bugs just went away, or to stay on our course and fix the regressions. And the decision was made to fix the regressions, even with the potential of slipping the product. And I think the product is much better because of it. And so that's one of the important things about threat modeling, is it helps you make those very, very hard decisions. So this is, as I mentioned, a tool that we have internally, and we're starting to sort of clean this up a little bit to make it available externally. The example threat model I'm going to show you just a very, very quick look at this one threat model. It's actually kind of funny. The person that wrote this, when he was showing me this threat model, it was kind of funny because I had performed a very similar threat modeling process about 3 years ago on what was known as Stinger back then, which was the Windows CE for mobile devices, for cell phones. It was the code name Stinger. And it was actually kind of funny looking at this, is because some of the threats that Frank had identified were somewhat similar to some of the threats that we had identified when we were doing the threat modeling process for Stinger. So, as James mentioned before, a lot of it's just background information. What are the use scenarios? How is this device going to be used? You need to know these things because that helps you determine what the boundaries are as to what is acceptable and what is not acceptable. And so there's a bunch of scenarios here that you can document. What are the external dependencies? You know, what do we depend on? So, for example, this is a phone, a cell phone. Well, it depends on the actual the network being there, the mobile network itself, etc., etc., etc. What are the external security information and so on? You've got to have this background information because that helps you make decisions further on. Probably one of the most important aspects of the threat modeling process is understanding where the data came from. Where does the stuff come from? What are the entry points into the application or into the solution? And once again, James mentioned this. If you can identify all those input points, then you know where the data came from, and you can determine whether the code on that code path is actually secure or not. So the first thing we do is, okay, we've got this cell phone. What are the entry points? Where does the stuff come from? It comes from the handset, it comes from the keypad, telephone line, etc., etc., etc. One of the most important aspects here also is understanding the trust levels. What level of trust is required to initiate that data flow or to access that entry point? So let's take a very simplistic example. You have a black box that has two input points. One is anonymous, one requires the admin. Which one's the bad guy going to go after? The anonymous one, because he can. He's not going to go after the admin one because, frankly, if the guy's already the admin, your problems have just started anyway. So this is really important, understanding where the entry points are and what level of privilege is required to actually initiate that flow. This is just a listing of the trust levels themselves. What resources are we trying to protect? A very important aspect is the data flow diagram that James also mentioned. And so what we do in here is we can host Visio, and Frank has written a Visio template, which is a DFD template, which we built up. We added a little bit more to the template to support trust boundaries, because the notion of trust boundaries isn't in normal DFDs. And so this helps you understand where all the stuff comes from and the interrelationships between things. And here's another one, accessing the remote interface and so on. And then underneath this we have the actual threats, and this is where the real work is done. So there's a threat that an unauthorized user can gain access to a remote administration interface. There's a thing called a threat tree that we have. What are the conditions which must exist for the threat to be real? These conditions must exist, and then we have this particular condition can lead to a threat. There's a text way of representing that. We also have built into this a graphical way of representing that. And so, for example, for this threat, an unauthorized user gains access to the remote administration interfaces. There are two conditions that must exist. The remote admin is enabled. That function is enabled. And that's what the bars mean across the two nodes. The remote user dials the phone number for the phone. And then any other conditions that must exist. The reason why a threat tree is very, very useful is when it comes to mitigation, one of the rules that we use is look at the threat tree and look for the highest level AND clauses in the tree. So if this were a whole series of nodes, just as a simple example, down the right-hand side here, and just a single node here, then if I could mitigate this condition by removing this condition, whatever that means, the whole thing is mitigated. I have really mitigated the threat. I am now using some technology or technique to really fix a problem. And so threat trees are really useful because you look for these high-level AND clauses. What it's also useful is if you have a mitigation that's really far down in the tree, that may just be a defense in depth mitigation and not a real fix for the problem. So we look out for those as well when we're reviewing threat trees. Once again, this is the whole bunch of threats underneath this. Spoofing and stride stuff is taken into consideration, and dread, what's the overall risk, etc. This is a WinForms app. It's written in C#, and as I mentioned, we expect to make this available soon. I don't want to commit to an exact date just yet, simply because we just want to clean it up and get it all ship-shape before we hand it out. The chances are we'll see it soon on got.net. Now, something to be aware of is that this app would not actually work if this tool were running from a network share. And the reason why it can't run from a network share is because it writes files. And because something comes from a network share, there's only a certain level of trust that that code is given. And so I want to bring back up on stage Matt Lyons to give a quick explanation of some of the code access security issues that you should be aware of, and hopefully give an insight as to why the threat modeling tool would not work if it were run from a network share. Hand it over to Matt.
All right, I'm just going to give a really brief walkthrough of code access security, and I just want to start with a little bit of the motivation behind it. Why did we even create it in the first place? Well, as Michael was talking about, when we're sharing applications, there's a lot of ways to do it. We can put it on a file share, we can put it on a website, we can use ActiveX controls, we can use scripting. There are many solutions out there. But most of the solutions that we saw before we brought in managed code with code access security was that there was a big struggle between richness and safety. On one side, we had solutions like ActiveX that were very rich and allowed us to do just about anything we wanted to. But the controls around that are just, do we want to allow it to run or not? Once an ActiveX control is up and running, it can do whatever it's going to do. And on the other side, we've got solutions like scripting, which are generally pretty safe, but they're not as rich, and they're pretty constrained in what they can do. So we wanted to bring managed code into the picture that somehow bridges this gap. And it does so by the safety mechanism primarily of code access security. That provides a sandbox for applications to run in. Code access security allows, say, that stock ticker written in managed code on a web page to show you the price of some stock without being able to take over your machine. And it does this through the fine-grained controls that are listed out as permissions. And of course, managed code has richness that we've been talking about during the whole PDC at the different sessions, but there's even a lot still today through a lot of the built-in class libraries, the extensibility that ISVs and applications add in, tool support, and there's a lot that managed code brings to the table. But let's look a little bit more at code access security and the sandbox mechanisms of fine-grained permissions. Now, permissions are demanded before a resource is accessed. So, for example, before using the built-in file class to read from a file, there will be a file I/O permission that says, okay, we're going to look at file c:\foo.txt, and we want to open it for read access. And that permission is demanded, and the managed code is checked if policy granted that permission to the code before the resource is accessed. And there are permissions for all kinds of resources in managed code. I mean, there's files, printing, everything I have listed here, and a lot more. And as we move into Whidbey and into Longhorn, there will be more resources that we open up with other permissions that you can define limits of the sandbox. And the way, now I had mentioned earlier, policy control is how permissions are granted to managed applications. And there are 4 contributors to policy. There are enterprise administrators, machine administrators, users, and developers. And each of these four groups gets to have the say in the policy. And if one of them is going to say, I'm not going to allow any code from, say, the internet to run, then it blocks out that ability. It's the intersection that defines what permissions are given to an application. But fortunately, enterprise administrators can deploy policy changes for users and machine administrators so that they don't really even have to worry about managed code policy at all. It can be taken care of behind the scenes. And the default policy for managed code is based on Internet Explorer zones. So the My Computer zone would represent some application that you had installed on your machine. So take the threat modeling tool, for example. You're just going to install this on your machine and you want to be able to read and write files. Well, that's going to be somewhere under program files that you've installed. You just want that to work. But something coming from an intranet share, you have a little bit less control of. So by default, we've cut back the permissions that are given to those applications. And again, on the internet zone, there's even a lower level of trust than the guy down the hall who's opening up a file share. So we even have a smaller set of permissions given to that. So this policy mechanism by default gives you it fulfills our secure by default goal of giving permissions just where we believe they're needed by default for users. And we have the distributed policy control so that administrators can raise or lower the bar as necessary. Now, something that you've probably heard of if you've gone to some of the the WIDBE sessions is click once deployment. Now, click once deployment is a new deployment technology for WIDBE that we believe will increase the prevalence of application sandboxing because it makes deploying applications with limited trust much easier. And it does so by using application manifests that define all the permissions that an application will need before it even runs. And if an administrator had pushed down policy to say, we'll give this application this, some X set of permissions, and the manifest says, I'm just going to need X set of permissions, then you can just run the application. But there's some additional flexibility with click once deployment, where if an administrator chooses so, they can also defer the decision to the user. If an application needs more permissions than would normally be granted by policy, a dialog can be popped up to the user to allow them to run something or not. But obviously, you want to avoid using more permissions than are granted by policy if you can somehow allow that. And so I'll turn it back over to Mike here, and he can introduce some tools that will help you write managed code, or write tools and applications in managed code that use semi-trust, but it will allow you to write those easier so that you don't have to worry about these problems with needing more permissions than given by policy. So,
thank you very much, Matt. So before I bring Stephanie onto stage, I want to tell you a little story. So first of all, how many of you have debugged security problems at some point? How many of you enjoyed it? That's funny. Hold on, there's one sick puppy at the back with his hand up. Debugging, one of the big problems with security, and this is something I hear all the time, is security is great so long as no one gets an access denied error when they're doing the normal course of their duty, because it's very hard to determine what the problem was. In fact, I want to share with you an interview question that I used to use. I've updated it slightly to accommodate ASP.NET. So just bear with me. This is an interview question that I've often used, especially when I'm particularly cranky. Here it is. So a user's got a client browser running some JavaScript that takes a username and password. And the reason why there's JavaScript there is because it takes username and password, takes the password, does a SHA-1 hash, salts the SHA-1 hash in JavaScript, sends a request over to a web server over SSL. The web server is an IIS web server, has an ISAPI filter, takes the username and the password hash and the salt, uses that to do a database lookup in the ISAPI filter in an Oracle HR database. It then calls an ASP.NET 1.1 application, which is running with partial trust. That ASP.NET page writes out a page hit counter to the disk. It also queries a SQL server. The SQL server code is calling a stored procedure using parameterized queries, so there's no SQL injection attacks. Updates a couple of tables in SQL Server through a stored procedure. On those tables, there are update, insert, and delete triggers. The same ASP.NET page then calls out to Host Integration Server, aka SNA Server, which communicates over LU 6.2 to an AS400 running OS 400. That's not an unlikely scenario. The user types in the username and password, hits the submit button, and gets an access denied. Where was the error? I wish you the best of luck debugging it. So anyway, one of the aspects of this is debugging permissions and running code, running code on your machine. It ran perfectly well. And all of a sudden you run it in some other environment. It's like, oh my goodness, it doesn't work anymore. I wonder why it doesn't work. And on that note, I would like to ask Stephanie to join us on stage to demonstrate a new feature of Would-Be called F5 in a sandbox. You don't need to use that.
Thanks, Hello? There we go. All right, let me try and reset a little bit here. There we go, that's better. My name's Stephanie. I'm here from Visual Studio to show you some of the new tools that we've built to help you build applications which are more secure by default. So Mike Nash talked about secure by default and how Microsoft wants to help our customers build applications which are secure by default. Now, what we've done is, as Matt talked about, we've built a sandbox for applications so that when applications run, by default, they don't have access to some of the protected resources on your system. So this is a backup measure. So let's say you have an application which is running, and you want to make sure that the application can't do things like access your file system or access your registry if it's not supposed to be able to. Now with Click Once deployment coming out in Would-Be, and then Avalon applications will be deployed by Click Once as well, very prevalent for WinForms applications, Avalon applications. Click Once applications run in the sandbox by default. So the application's level of security, or level of privilege, is determined by where the application comes from. So what I'm going to show you today is the set of tools we built to help you understand how your application will run inside that sandbox, and also to see how you can change the application if you'd like to make sure that it has the least amount of privilege that it possibly can, or to increase the size of the sandbox if you do want your application to be able to perform operations like accessing files or accessing the registry. So here I have a simple application that I've built, and I'm going to deploy it using Click Once deployment. What I'll show you is how the application runs inside the sandbox so that you can see what we're talking about when we say sandboxed application. We're going to go to the project menu here and publish this project. This will be fairly familiar for a lot of you who've seen Click Once deployment in the keynotes and in the talks we've given earlier this week. I'll deploy this application out to my IIS server. I'm going to make it available online and publish the application out. This is performing a build of the application, creating a website on IIS, and finally it'll move the files up to the website and give me a web page that I can deploy from. So here I have my application, and I'll click on it to install. And you can see that what I have here is it's a very simple application that I built to take notes inside of Windows. So I can use this, take some notes, and draw pictures. Nice. Say I want to save this. All right, so you can see what happens inside the sandbox. What I'm trying to do here is save this file out to disk. And the error that I'm seeing on screen is exactly what your users would see if you were to deploy this application into production without testing it first. It's a pretty tough error for an end user. This is a file I/O permission. I have a feeling most people in your enterprise aren't going to know what that is, nor do you want them to be running into errors like that. So let's go back into Visual Studio, and I'm going to show you how you can prevent this kind of error from being seen by end users. So here I'm back inside Visual Studio with my application. And I'm going to show you how in Visual Studio we now support setting up a sandbox around the application inside VS. So you can see how it behaves as it will behave deployed into production. We've added a new property page to the project properties. And here we allow you to configure the sandbox for the application. I can set the set of permissions that I think the application requires, and also imitate the deployment environment by setting the URL that the application would be deployed from. So in this case, this application I'm going to deploy inside my intranet, where the intranet is defined as inside my enterprise. And for those of you, I know this screen is a little bit hard to read, so I'll give you a little bit of data about what I'm showing on screen. The intranet is the zone inside the enterprise, so http://PDC 2003 would be an intranet site. And the set of permissions that are given by default are permissions like reflection. I can perform reflection over an assembly. DNS. Printing. The second thing that I'm going to do to configure the sandbox is set the URL that the application will be deployed from. In this case, let's use a simple URL. This is exactly what I was using before. Just replace this with the machine name. And I've now configured the sandbox around the application. So let's see what happens this time when we press F5 and run this application inside of Visual Studio. So VS will build the application and run it. And the application is now running inside the sandbox with a restricted set of security permissions. If I try and perform that save as operation, what Visual Studio has done is it's caught the security exception which has been generated because we were running inside the sandbox, and it's dropped me out on precisely the line of code that caused the violation. So I can see here exactly what's causing the problem. And as what Michael was saying, what we found for our customers was one of the hardest problems was identifying where in code security exceptions were coming from. So we can see why this application would have a problem and correct this in advance. Now I also get the security exception helper here, which is a dialog which gives me information about what I can do to correct the problem. There are links in here which will take you to help topics that talk about what exception it is you're seeing. In this case, the file I/O permission. I can get more information about what is file I/O permission. And I also can get information about how to prevent this kind of security error. There are three things that I could do. The first would be to remove this block of code. That's probably not what I want to do here, because I want to be able to have save functionality in my application. My second option would be, as Matt Lyons was describing, I can deploy security policy into my enterprise, where the security policy says, I want to trust this application. I trust Microsoft as a publisher, or I trust specifically this application, and I want to allow it to perform file I/O or registry write, whatever exact permission this application requires. The last option would be to specify the set of permissions which is required here. And when the application is launched and run, the operating system will compare that permission set to the default permission set. And if the permission set I'm requesting is greater, it'll prompt the user. Say, this application wants access to more resources on your disk. Would you like to grant it? And that's what I'm going to do in this case. So again, Visual Studio provides me easy tools to configure the set of permissions required. Let me stop debugging. So I'm going to go in, and what I'm going to give the application permissions for is, I'll just give it all the permissions it needs. And I can do that by setting the zone to my computer, which gives it all the permissions that can possibly be granted to any application. Click OK, and now we'll redeploy the application. This dialog is reentrant. For those of you who have seen Click Once Publishing, you'll know that all the settings are saved, so I can simply go ahead, republish the application. Everything is saved. And now when I try and install, you can see that the first thing that I get is a prompt which says, this application wants to perform some privileged operations. Do I want to allow that? And I can say, yes. In this case, I want to allow this application to do whatever it is that it wants to do. Let's try the save as operation. And this time I'm able to save the document successfully. So this is an example of how we in Visual Studio are helping customers to write applications which are designed to run more securely inside a secure sandbox, and also to see how it is you may want to expand that sandbox or change your application to modify it and work better inside the secure execution environment. Thank you.
Thank you very much, Stephanie. So one thing that Stephanie showed was some runtime environments or some runtime tools that we can use now, and would be to help detect certain kinds of security violations or security issues, and certainly help developers write code a lot faster. I now want to bring up Anthony Moore to demonstrate another tool that we can use called FXCop, which rather than doing it at a runtime can actually analyze the code in binary form. Anthony.
Thank you. I'm going to be showing you FXCop, and this is a tool that will let you write more secure code today. And it will do that in 3 key ways. Firstly, it will analyze your code and actually find security errors or indirect logic errors that can lead to security problems. Secondly, it's a great way to learn about the framework and code access security. And thirdly, it's a very useful tool in a security push like the one that SQL Server did. So I'm going to start FXCop now. FXCop works by doing an analysis of the IL and the metadata. This is the binary format of managed code. And this is a free tool that you can download today. It works with version 1.0 of the framework and 1.1, and it will continue to work with future versions. But this is on a separate release cycle, and we release a new version of this every 6 months or so. And the version I'm showing you now is the same as the version you can download now from the internet, and there's a link to that in the resources you have. There's also a copy on the CDs for the PDC, and the version I'm showing you right now is identical to that version with one difference, which is these nice big chunky fonts everywhere. So let's take a look at these rules here. So FXCop has about 150 plus rules. And these are specific patterns of code that it looks for that can indicate problems. Now, like a lot of other tools, FXCop was not originally designed to be just for security. It was actually originally designed to enforce design guidelines, but it turned out to be useful for finding all sorts of other problems, such as performance, security, suspicious usage patterns with the classes in the base class library. So let's take a look at some suspicious code patterns that FXCop can analyze. I'm going to start up Visual Studio 2003 now. And I'm going to create a new project. And I'll create a C# class library. And class libraries tend to be very important from a vulnerability point in managed code. Okay, that's an empty project. I'm going to paste in some code that has some funny patterns in it. And I will just make sure that will compile. So the first one is a read-only array. So in managed code, the read-only property makes a field such that you can't reassign anything to it. But it can be misleading because if you create something that is inherently mutable and put it in a read-only property, it won't magically make it mutable. So this read-only array, you can't assign a whole new array to it, but you could go in and change what all those numbers were. So any code relying on this data staying the same, any security-sensitive code could break. So another assumption that people generally make when writing managed code is that an internal function cannot be called from the outside. That is, you can do something arbitrarily dangerous in an internal function as long as it's not re-exposed. But an internal virtual function actually can be called from the outside. And the reason is that it's only some languages that enforce that you can't get at virtual methods that are internal. It's not something that is checked by the runtime when it executes. So the other thing I want to show you, Matt showed a great example of this earlier on, which is a Turkish eye exploit, an exploitable Turkish eye problem. In this case, it's doing an ignoring case comparison, and this can be spoofed by changing your regional options to Turkish and then typing file in uppercase. And in this case, it would be bypassing this demand. So I'll show you how to use fxcop to go and analyze that. We just say project add targets. And I'll add that library. And now we just analyze that. So it's found a number of suspicious things with our code. Firstly, it's saying fields that are arrays should not be read-only. It's detected that fairly simple code pattern and is telling us not to do it. Here we can see it's saying that an unsealed public type should not have an internal virtual member because it can be called from the outside. And this one here is interesting. It's saying culture info should be passed, and this is actually a globalization rule. But let's drill into more about this. It's saying that this method is doing a string compare that should pass in a culture info, and this is the mitigation we recommend for Turkish eye problems. Use the slightly longer versions of string compare or two upper or two lower, and explicitly say, I want the current culture because I'm displaying some UI, or I don't want the current culture because I'm dealing with something symbolic. Now, it's also complaining about a few other things that I didn't paste in, so let's take a look at those. Here's one where it's saying, avoid having a namespace with a small number of types. Well, I think that's a bit rough because I'm just getting started here, so I'm going to make that go away. I'll say, I'm just getting started. Now, if I reanalyze, that rule, that violation will no longer appear, but it's not gone forever. It's been stored in this project file, and that's available for later reporting. And this is very important when you use fxcop in something like a security push. Now, these weren't particularly challenging things for fxcop to find, so I want to show you some more advanced patterns that fxcop can detect. Now, this method here is protected by a code access security construct called a link demand. And a link demand is a fickle mistress. A link demand is very fast because it has minimal overhead at runtime. It will protect your code from unsafe callers. But it's dangerous because it works by enforcing a check when external code binds in. And this means it doesn't do a check when a call comes from inside the same assembly. And there's other code access security constructs that don't work that way but are slower. In this case, there's another method calling it from the inside, and this is just fine because this is not publicly accessible. But that method is in turn being called by this method down here that is exposed publicly and does not itself have a link demand. And this particular pattern we can see fairly clearly, but these chains can get very complex, and this is the sort of thing that it is very hard for an individual developer to track down. The tool support here becomes very helpful. I'll just build that. And let's analyze that in fxcop. Now I've reanalyzed this, and the new violations have come up in bold. And you can see here that if I drill into this, it's saying this is a suspicious calling chain that will lead to a bypass of that link demand. And one more thing that's worth looking at here. Here is a very low certainty rule. It's saying event handlers require a security rule. And we can drill into that a little bit. All of these rules have very extensive online help. But this is quite a complex potential exploit that can result from stitching a publicly exposed event handler to something that will take an event, and they could both be fully trusted, so you could lure one thing to calling something else and bypass the link demand in that way. But it takes a lot of human investigation to determine if this is a real exploit. So a good practice in a security push is to take a number of the security rules and reactivate them all and have someone do another pass through them. And the project system and the exclude mechanism here can become a very important part of the security push. So that's FXCOP. It'll find bugs, it'll help you learn about the framework, and it's pretty darn useful in a security push. Thanks.
Thank you very much, Anthony. The two tools we've just seen, F5 in the sandbox and the FXCOP, are obviously aimed exclusively at managed code, through the use of metadata and through analyzing permission failures and so on. There is still one heck of a lot of code out there that is not written in C# or VB.NET or any managed environment. There's a lot of code being written today, and there's a lot of code that will be written tomorrow in C and C++. And there are issues that need to be analyzed in those languages as well. And it gives me great pleasure to invite Chris Weisopel from @Stake onto the stage to demonstrate a tool and talk about some of the aspects of a tool called Safe Apps. Thanks, Chris.
Hi, thanks, Mike. So we heard a lot today about all the different kind of flaws that can creep into your code if you aren't an expert in secure coding. We also heard today how tedious and time-consuming and slow actually doing code reviews are. So Safe Apps is a program that @Stake is going to be releasing as a product that automates this process. And what we've done is we've taken all the knowledge that we've built up as a security consulting company. We've done over 200 code reviews and application security assessments, and we've taken those rules, taken rules from external sources like the Writing Secure Code books and other sources, and we've implemented them in this product to automate the code review process. An important part of automating the process is to prioritize the risk. When there's a flaw, you want to say if it's a severe error, prioritize it that way. If it's something that sometimes could probably be a problem, make that a possible error. If it's things that it's insecure coding construct, but it's not particularly exploitable, you want to make that just sort of a warning to be warned about that. The target user is a developer, could use it during the development process. They check in their code, they could run it right afterwards. It could be used during the QA process, or it could be used by a security engineer who may be looking at many applications in a whole company in a centralized way. If you're not doing code reviews because you lack the expertise or you don't have the time, using a tool like this can drastically reduce the flaws in your program. So what's unique about it? The way we've built it is it's a completely extensible program. There's new flaws coming out all the time, new classes of flaws. And the way we've built it is we've built it with an engine that actually does the binary analysis of the program, builds control flows, data flows, propagates the range of buffers and integers. And then we also have, so that builds the model of the program, and then we have a scripting component where you can write a simple script which will walk those models to find the vulnerabilities. We built the program to work on binaries because we think that binaries will allow the deepest security analysis possible. There may be things that you can't find from just looking at the source. One nice thing you get out of it is you're not looking at any dead code because we do a call graph tree, and if it's not called, we're not analyzing that. If there's things that your compiler is doing with structure packing or implementation details, those aren't hidden from the analysis. If someone's actually trying to put a backdoor in, which is a concern these days, especially with people outsourcing and offshore outsourcing of coding, they're going to try to obfuscate that in the source code. It's much harder to hide from binary analysis with things like backdoors. So just some of the things before I go into the demo we're looking for the lowest level things, those language and standard library issues, those memory copies, buffer overflows, sprintfs. We're also looking at things at the platform API level. What kind of things are, you're not checking return codes on security critical APIs. And we're looking at high level issues, things like backdoors. Are you doing input validation? So let me switch over here and just give a quick demo. Instead of creating a new project, I have a program that I've already done the binary analysis on here. It's a finger program. I'm just going to load that up because the binary analysis is the thing that actually takes the amount of time. It takes a significant amount of time. Running the scripts to find the security flaws is fairly quick. So I've loaded that up, and I have a set of scripts here that individual scripts are looking for certain types of problems. I'm going to run the full security analysis, which will run all the different scripts, and it's running through the model now. It gives me a summary of the different types of severity of the errors I've found, summary of some of the different types, and we export reports that tell this. But the important thing here is the in-context view where I can double-click on an error, and it can bring me right to the line of code where that flaw is. And if I actually click on this icon here, I get a better description. It's telling me I have a severe error here. This call to stir copy appears to contain a buffer overflow error. Source buffer appears to be 100 bytes, and the destination buffer is 50 bytes. Now, it doesn't just do a grep and find string copy. What it's done is it's found that, but it's done data flow, and it's looked up here and seen that the in-buff size is 100 and the user is 50. So that's flagged as a severe error that needs to be fixed. If you look right up above here, I have another stir copy, and that's just flagged as a warning because I should know that I'm doing an unbounded operation there. But in this case, I'm moving in-buff, which is 100, into host, which is up here, malloc at 200. So I'm moving something from a smaller buffer and a larger buffer. It's actually not, there's no potential overflow there, but since things might change over time, I might want to change that anyway. If I move down my list here on severity to the next most severe error here, I get to this line of code where I'm setting host element 0 here to null. What's wrong with that? Well, the detail's telling me that I'm using the results of the malloc above without checking for the success. So in a lot of cases, people will, assign a return value, but then they'll go ahead and use the results of that function without actually checking it. So we actually check to see that there was some sort of conditional statement done that evaluated the return before it was used. I just want to show you one more. If I go down to the next error, you can see we're finding an sprintf statement here has unbounded %s's, which could result in another buffer overflow. It's a very, very common error we find is the whole printf family of functions just because of this. People don't really realize that they can use format precision specifiers to fix it. So here in the long message, we're telling the developer what the error was and giving them some guidance. Use format precision specifiers to mitigate the problem. So you don't have to be a security expert right away, but as you start to use the tool and start fixing your problems, you're gonna learn right along, and hopefully next time you won't generate the problem. So that's it for my demo. I just wanted to put a URL up here on the page. If you want more information, you can go to atstake.com/safeapps. Thank you.
All right, we're on the home stretch. I realize that having you seated for 4 hours is almost cruel and unusual punishment. The few little housekeeping things I want to make you aware of. First of all, just want to wrap this up. There is no silver bullet for writing secure code. I really wish there were. I truly wish there were, but there aren't. There are many aspects to building secure software that you must be aware of. Education, good coding practices, good process, and so on. And you need to be aware of the fact that threats are constantly evolving. You should be considering your own security awareness program within your organization for developers and for the whole engineering staff. Consider doing a security push if you've not done one of these things. There's a lot of great tools. You've already seen a plethora of tools that are available to you today and tomorrow, as well as following best practices which are documented in writing secure code and on MSDN. You should be very seriously thinking about testing on Windows XP Service Pack 2 and Longhorn. And the reason why I say this is over time, we will start driving the attack surface of those products down. And stuff that may work out of the box today may not work correctly without being tweaked tomorrow because the ports may be closed or that feature, that service may not be running. So I urge you to test on those products as soon as possible. There is a symposium that starts at 1:45 back in this room where you can ask a whole bunch of people a whole bunch of questions that have been on your mind. At 12:30, Jason Garms will be presenting in this room. And he'll be presenting on the new safety features that we are adding to Windows XP Service Pack 2. And you should be aware of those issues as you're writing your own software because, like I say, some of those changes will have an impact on your code. Finally, there's a security survey. Please fill out the back side. The first people to fill out the back side will receive a spy pen, which will allow you to write your passwords down on a secret piece of paper and only see the password by holding the pen. I told you we got this security stuff. Finally, the first 800 people who arrive at the Security Symposium panel will receive a copy of a new MS Press book from the Prescriptive Architecture Guide people, Improving Web Application Security, Threats and Countermeasures. If you think writing secure code is a big book, this is the same size. So you get to take 2 books. So those of you who are complaining about the size of writing secure code, you've got an opportunity to make your life even worse. We have literally 5 minutes if you wish to ask any questions of us. Failing that, we will be available. All the people at the front in the blue shirts will be available in the back if you have any comments. And then Jason will be up at 12:30. So if there's any questions, please feel free to use the microphones. One question there, yeah.
Since Microsoft's security push and the Trusted Computing Initiative, there still have been a fair number of vulnerabilities. What have you learned from those vulnerabilities, and how have you modified your practices as a result?
That's a really good question. So the question is, there are vulnerabilities even since the security push and so on, and the introduction of trustworthy computing. I think it's fair to assume that vulnerabilities will always exist. We're not saying this is a perfect process. One thing we do, though, and this is a very important point, is when issues are found, we do a very in-depth root cause analysis. What was the problem? Why didn't we find this? Was it a design issue? Was it a coding issue? Was it a testing issue? How can we make sure that never happens again? And we're feeding that back into the process. This is an evolving process. Next question.
Where can we get that SQL injection test tool? Not test, but the...
Where do you get the SQL injection tool, James? The SQL injection tool. Where can people get the SQL injection tool?
SQL injection tool is available on the Application Security Incorporated website.
Application Security Incorporated website. Is that like AppSec Inc. or something? Yes. AppSec Inc. There you go. .com. We can say one more, and then Jason has to come up and prepare for his talk at 12:30. Yeah.
It's not so much a question, more, well, an open would be nice to have. You talked about having like a checklist for developers. What would also be useful is a checklist kept alive by ongoing updates for project managers, so that I could get them all chasing the developers to keep up to date.
That's actually a good point. I mean, we have checklists for developers, testers, and design. And you'll talk about another kind of checklist.
I'm thinking effectively whether you've got, you know, outsourced code development or your own developers. Something by way, people that aren't technical, I can point them at there and say, keep up to date with that and use this as the measuring stick.
That's actually a really good idea. Why don't you email me? We'll come and see me at the end, and we'll get a dialogue going.
Mike@microsoft.com, right?
Thank you.
Mike, do me a favor. Mention that the slides are on ComNet and MSDN because everybody's asking.
Okay, everyone's asking whether the slides are available. They are on ComNet and they are on MSDN. They will be on MSDN. I'm sorry. Well, thank you very much for your time. Have a good lunch. And those who wish to listen to Jason, he will be back talking about XPSP2 at 12:30. Thank you very much.